This video is an introduction to the topic of plate tectonics for Year 9 Science. And the topic basically covers everything from the theory of plate tectonics, evidence for plate tectonics, natural disasters like earthquakes and volcanoes, and even the use of technology in studying the Earth's structure. So I'll begin with some definitions. Geology. Geology is basically the scientific study of the Earth. Okay, its materials, its processes, the history behind it, and the changes that have occurred over time, right? And the scientists who study the Earth, study geology, they're called geologists. They study the Earth. And so what is the Earth? Well, the Earth is basically the third planet from the sun. It's basically a sphere, roughly to a degree it's a sphere, and it's about 70% water. Okay, so most of the Earth is covered in water, and the rest is land, so continents. And a continent, by definition, is basically a large continuous landmass, okay, on the Earth's surface. Okay, there's the Asian continent. You've got African continent. You've got North America. You've got South America. You've got Antarctica, Europe, and Australia. So you've got 7 continents on the Earth. So let me now get into the Earth structure, the basics of Earth structure. So let me draw a diagram here. So I'm drawing a 2-dimensional picture here of the Earth's inner structure. So if you could slice through the Earth, right? If you could slice through a 3-dimensional object like a sphere, you get like a 2-dimensional thing, which in this case is like a disc, a circle. Try and draw this as best I can. So these should be concentric circles, roughly, right? Circles with equal radii. So the way I like to think of the Earth structure is basically like a giant candy-filled cupcake, if you wish, with different layers. So at the very top here, outer layer of the Earth, we've got the crust. So think of the crust of even like a pizza, right? The crust is on the outside. It's the crispy outer layer of the Earth, of the cake, if you wish. Okay, it's where we live. It's where everything happens around us. All the oceans and mountains are found. And it's roughly anywhere between 7 and 50 kilometers thick. Now, you're not expected to know these numbers for an exam, let's say. It's just nice to know relative numbers, relative sizes. And this drawing doesn't do it justice. The crust relative to all the other parts of the Earth, layers of the Earth, is actually very thin. The next layer you've got is the asthenosphere. That's anywhere from around roughly 100 to 200 kilometers. Okay, so much thicker than the crust. And the word asthenosphere actually comes from 2 Greek words. Asthenes, I think that's how you pronounce it. Asthenes. Okay, that means weak, which roughly translates to weak. And sphaira, I think that's how you pronounce it, meaning sphere or ball. Okay, it's a weak sphere or ball. Now, if you can picture the asthenosphere in 3 dimensions, it's a sphere. What I've drawn here is a 2-dimensional representation when you cut through the Earth. Okay, and the term asthenosphere was first introduced in 1909. And the asthenosphere consists of the crust and what's called the upper mantle, which I'll get to now. The thickest layer of the Earth is the mantle. This thing here. It's the mantle, the thickest layer of the Earth. Think of it as like a hot and gooey caramel layer in your cake. It's mainly solid. Okay, but it also behaves like a thick, slow-moving liquid. Okay, so it's not stationary. It's not just sitting there. It's doing something. It's moving, and it's around 2,900 kilometers thick. Okay, so it's the thickest part of the Earth. And at the very center of the Earth, we've got what's called the core. Now, the core can be broken up into what's called the outer core and the inner core. Okay, the very center of the cake, we can even think of it as like an apricot, the center of an apricot, the kernel, and the core is believed to be solid. Okay, though it's not definitive, because no one's really been to the core, but based on measurements, scientists believe that it's solid. And it's believed to be made of iron and nickel. So it's believed to be made of metals, iron and nickel. These are two metals. And it's actually responsible for generating Earth's magnetic field. Okay, so magnetic fields are responsible for, Earth's magnetic field is responsible for protecting us from things like cosmic rays and dangerous radiation from space. Okay, so the metals making up the core, they have this magnetic field. Okay, so think of it as like a bar magnet north. Okay, north is up there, south is down here. And there's an invisible magnetic field that we can't see. And so that's the basic structure of the Earth. It's got the crust on the outside, the asthenosphere, the mantle, and the inner and outer core.